So I think in the next few months we're going to be talking about my most favorite region in the entire galaxy many times. The central region, the galactic center. The region that kind of looks like this if you were to look at it using some kind of a time-lapse. You can sort of see a lot of stars orbiting the center, and that's of course Sagittarius A star, the supermassive black hole right in the middle of our own galaxy. But the reason we're going to be discussing this region quite a lot is of course because a lot of studies using James Webb Space Telescope are now focusing on this specific region because James Webb was able to conduct a lot of detailed observations from here and is going to be doing even more in the future, and also because James Webb is an infrared telescope. It's able to physically see through all of this dust and actually reveal what's on the inside. And naturally it's already made some really incredible discoveries, the ones we discussed in one of the previous videos, that should be somewhere in the description. But today we're going to discuss a few more discoveries, and some that actually are sort of surprising. Turns out that at least one of these stars is very likely not from this galaxy. It came from somewhere else, traveling for approximately 10 billion years from a distant galaxy that no longer exists, with additional discoveries from this region you see right here, often referred to as the brick. And so, hello wonderful person, this is Anton. Let's discuss the central region and discoveries from the black hole once again, and talk about exactly what's happening here based on recent observations. But first, let's start with the basics in case you've never heard about this region before. In this case, this is the region of the second picture from a black hole taken by the Event Horizon Telescope team. This is basically what we think the region around the black hole potentially looks like, at least in radio light. These are radio emissions, so this is obviously not optical light. But more importantly, for decades now, the scientists have been observing the motions of the star in this region, eventually realizing or basically confirming that there is a really massive object right in the center. The confirmation for the existence of Sagittarius A star, supermassive black hole, with a mass of 4.3 million solar masses, and a few scientists won the Nobel Prize for this a few years ago. But one question that was not answered before, and one question that's, I guess, sort of important is, so these stars. There are so many of them here, but where exactly did they actually come from? What's the origin of all of these stars very close to the black hole? And I guess more specifically, is there any chance that some of them were actually formed here, or did they all migrate from somewhere else? Now, quite a lot of these stars, especially the ones very close to the supermassive black hole, have a name. They're known as S stars. And I think the most famous one must be S2. Or I guess more specifically, the most studied and the most well understood. Its orbit is known exactly, and it was even used to prove a lot of Einsteinian ideas that basically show us how some of these stars have a very unusual precession that would not exist unless there was a very massive object in the middle. And so this star is definitely there, it's quite well understood, it has a very unusual eccentric orbit, and it seems to orbit in this way. Although this is obviously accelerated, with the true orbital period being approximately 16 years. But because the environment around the black hole is so extreme, nobody actually thinks these stars formed here. And at least there's no way to prove this or to even explain this. And so they must be migrant stars. They must have come from somewhere else. Interestingly, at least one video in the description talks about one of the most extreme S stars out there. At its closest approach, it moves around the black hole at the speed of approximately 24,000 kilometers per second. That's a very fast star, basically nearly 10% of the speed of light. But how can these stars get these unusual orbits, and where are they from? Well, at least one recent study managed to discover the potential origin of one of them. And it's nothing anyone imagined. Here we're talking about the star known as S06. It orbits approximately 0.04 light years away from the black hole, and surprisingly, it seems to be a really old star. Its age was determined to be over 10 billion years old. That's double of our own sun. But more importantly, by using the Japanese Subaru telescope, the Japanese researchers measured the quantity and ratios of various elements inside this star, determining that it looks very different from a lot of other S stars. Specifically that it seems to be not from the Milky Way. Or basically that its composition is just very different from anything we expect in this region or even in our own galaxy. Instead, its composition was very similar to what we usually find in various dwarf galaxies around the Milky Way. Somewhat similar to the famous Small Magellanic Cloud that actually does have a lot of ancient stars and somewhat primitive elemental composition, mostly because the material inside this galaxy is somewhat pristine and somewhat untouched, but it seemed to match even closer to the galaxy that used to exist but no longer does. Here the composition was extremely similar to stars in Palomar 12, a star cluster somewhat far away from us, and similar to Messier 54, a really famous globular cluster that's located a little bit farther away from the Milky Way, but we know came from a different galaxy. A galaxy whose remains are still here. Sagittarius dwarf galaxy that you sort of see right there. This unusual galaxy used to exist a long time ago, here we're talking about something like 10 billion years ago, and was a little bit smaller and a little bit less massive than the Milky Way. Eventually the Milky Way won a kind of a tug of war and slowly absorbed the smaller galaxy into itself. And we still see the signs of this absorption and this galactic cannibalism even today. This is known as the Sagittarius stream, and pretty much all of these clusters and all of these leftovers are still in the same location today. They're orbiting as a kind of a very long formation around the Milky Way and will eventually get absorbed into it with time. And surprisingly, or I guess maybe not surprisingly, all of the stars in the stream and all of the stars in these various formations seem to be almost exactly similar in composition to this star that just finds itself right in the middle of the galaxy. And it's about 10 billion years old. It's almost identical in chemical composition to everything else, which leaves us with only one possible conclusion. It must have somehow ended up here as the galaxies collided and as one star escaped Sagittarius dwarf and with time moved closer and closer and closer to the black hole, eventually assuming a very tight orbit around it. We don't really know exactly how long this process took, but it very likely has been here for quite some time, possibly even billions of years. Or, for all we know, maybe it actually traveled through the Milky Way for billions of years and has only arrived to this region recently. Mostly because we know that this region is somewhat hectic and there's a lot of gravitational interaction with a lot of other stuff, and so honestly nobody actually has any idea how long a typical star here lasts orbiting around the black hole before being dislodged and possibly thrown out of the galaxy or falls into a black hole, forming some kind of a super massive emission event. Like the one responsible for the famous Fermi bubbles that must have formed approximately 2.5 million years ago. And so by itself this is not an unusual proposition because we kind of expect some stars to maybe make their way toward the center. And obviously we expect galaxies to be swallowed as well. But I guess nobody actually expected to find one. The theory is theory, but here we physically find a star that must have come from a different galaxy destroyed by the Milky Way. So this is our first observational evidence that this seems to definitely happen. But there was actually an additional study of other stars nearby that was slightly farther away from this region and were also just as surprising. And here the scientists analyzed 3 more stars that were kind of unusual in terms of their composition and in terms of their age, discovering that all 3 seem to be much younger than what we actually expect, anywhere from 100 million to possibly 1 billion years old. And the reason this is unusual is because it kind of suggests that maybe, just maybe, there is definitely a lot of active star formation going on very close to the black hole, possibly formed as various very cold clouds collapse under gravity, creating various overdensities that then lead to new stars. At least that's the theory behind this. But when it comes to physical observations, we don't really see as many. As a matter of fact, the physical observations seem to be lacking. And so this recent study took a look at one of the potential regions that should be forming stars. This is known as the brick. As you can see from this image, it's not really that far from Sagittarius A star and from the central region. And so because it's so close, and because it's actually filled with gas, we kind of expect it to produce stars. This is an extremely thick region with a lot of different gas. And the recent discovery from the James Webb highlights even more that we expect this region to be a star-forming region. Here the scientists discover a massive amount of carbon monoxide, CO, way more than anyone expected, and basically just as much as we usually expect from a typical molecular cloud forming new stars. Normally, carbon monoxide forms ice particles, which then slowly coalesce and become larger and larger, eventually becoming planets, stars, and star systems. Yet nothing like this is seen around the brick. It seems to completely lack star formation, despite all of the necessary prerequisites. Especially because we know that stars seem to form here, so why not the brick? And it looks like at the moment we don't really know, but one potential explanation involves temperature. It looks like the brick is not as cold as it should be in order to start forming stars. Or basically, a lot of gas in the region here seems to be much warmer than it should be, very likely because of all of the activity from nearby stars and from the black hole, which sort of prevents certain regions from suddenly forming stars. If the gas is too hot, star formation is impossible. But we know that it seems to happen in other regions nearby, so there are basically some unexplained elements here, or unusual mysteries that nobody can explain just yet. But because the brick itself is so thick in dust and various materials, but does not have any stars or any star production, that's why it basically looks so thick, so dark, and so opaque. And why a lot of scientists want to understand exactly what's going on here. But at least for now, we still have some really exciting discoveries in regards to stars that were discovered, and the first ever extragalactic star that seems to orbit super close to the center. Another extreme S star to add to the list of extreme stars around the black hole. And if you want to learn more about these stars, check out some of the videos in the description. On that note, thank you for watching. We'll come back and talk more about this once there are more discoveries. Subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.